We are one step closer to answering the age-old question, are we alone in the universe?
It's big. NASA has hit the jackpot this time.
The quest for a habitable alternative to Earth has been ongoing for several decades. Elon Musk, the richest man on Earth, has invested approximately $100 million in this pursuit, but with no success thus far. However, everything has changed with the recent discovery made by the James Webb Space Telescope. This remarkable telescope has identified a potentially habitable planet, similar to Earth, that has captured the attention of scientists. What sets this planet apart and leads scientists to believe it could be the next Earth? Join us as we delve into the fascinating discovery of a habitable green planet made by the James Webb Space Telescope. The James Webb Space Telescope, JWST, is a groundbreaking instrument that revolutionizes space exploration and astronomical observation. This remarkable telescope is equipped with cutting-edge technology that's set to redefine our understanding of the universe. Unlike its predecessor, Hubble, JWST employs a massive gold-plated mirror specifically engineered to detect infrared light, permitting it to see through cosmic dust and observe remote galaxies, stars, and the genesis of planetary systems. Positioned beyond the Moon, it operates at an ultra-cold temperature of -233 degrees Celsius to evade interference from Earth's heat. The primary objective of the James Webb Space Telescope is to serve as a cosmic time machine, enabling us to peer back to the universe's earliest moments following the Big Bang. Its instruments analyze the faint light from the first galaxies, unveiling the secrets of the universe's history. However, the JWST also investigates the present and future, searching for unknown stars and habitable exoplanets. Regardless of its capabilities, it was surprising to the scientific community when it discovered a habitable green planet, but we will be back to that in a moment. One of its recent groundbreaking discoveries involves the identification of a potentially habitable, Earth-sized exoplanet. The James Webb Space Telescope's instruments are high-resolution and ultra-sensitive, capable of scrutinizing distant or faint objects that would render the Hubble Space Telescope's observations rudimentary by comparison. The centerpiece of the JWST's mission is its dedication to infrared astronomy. Infrared light offers a unique perspective on the universe, capable of penetrating cosmic obstructions caused by dust and gas. This is why the JWST is dedicated to observing the first stars and galaxies while characterizing potentially habitable exoplanets. One star that has captured the scientific community's attention is WSP-96, situated 1,120 light-years away in the Phoenix constellation. WSP-96 is a yellow dwarf star that offers enticing prospects for habitability by humans. Although it shares similarities with our Sun, it stands apart by being cooler and older. Surprisingly, scientists only became aware of these distinguishing characteristics upon its discovery in 2013. The Wide-Angle Search for Planets (WASP) program, in which WSP-96 is involved, is a collaborative effort comprising astronomers from various academic institutions. It leverages a system of robotic telescopes to perform ultra-wide-angle searches for exoplanets using transit photometry. These telescopes employ the transit method to detect exoplanets, scrutinizing subtle reductions in a star's brightness when a planet transits its host star. This collective endeavor resembles a cosmic surveillance system, monitoring the entire sky continuously. WSP-96b, a gas giant exoplanet orbiting WSP-96, has a mass approximately half that of Jupiter, making it a substantial celestial body. It orbits its host star at a proximity that's reminiscent of a neighbor living just a stone's throw away. The James Webb Space Telescope played a key role in this story. It conducted a comprehensive study of WSP-96b, resulting in astonishing revelations. The telescope identified water in the exoplanet's atmosphere, a discovery that has significant implications. Additionally, the JWST detected clouds and hazes in the exoplanet's atmosphere, a finding that deviated from initial expectations. This discovery of water on WSP-96b a scorching hot exoplanet situated at a fraction of the distance between Mercury and the Sun, has redefined our understanding of distant celestial bodies. The presence of water holds implications that extend beyond the specific planet and alludes to the potential existence of Earth-like exoplanets within the cosmos. This discovery poses a captivating question. How can water persist on an exoplanet with such extreme conditions? The answer delves into the history and chemistry of WSP-96b. WSP-96b belongs to a category of exoplanets known as hot Jupiters. These gas giants originally formed at greater distances from their host stars, where water is more abundant. They later migrated inward due to gravitational interactions with other planets or their host stars, subjecting them to extreme heating and tidal forces that expanded their atmospheres and altered their chemical compositions. The James Webb Space Telescope has been instrumental in studying the atmosphere of WSP-96b in great detail. Its suite of scientific instruments, including the Near-Infrared Spectrograph, NIR-SPEC, and the Mid-Infrared Instrument, MIRI, have provided valuable data on the composition, temperature, and structure of the exoplanet's atmosphere. By analyzing the spectrum of light from the star as it passes through the planet's atmosphere, scientists can identify the presence of different molecules, including water vapor. But that's not all. Let's look at other notable exoplanets discovered by space telescopes. NASA's efforts in space exploration go far beyond just the iconic WASP program. One of their remarkable programs is the Transiting Exoplanet Survey Satellite, or TESS for short. TESS is a space telescope that has played a pivotal role in uncovering and studying exoplanets. Unlike its predecessor, the Kepler mission, TESS covers an area a whopping 400 times larger. Let's dive into the fascinating world of TESS and its contributions to our understanding of exoplanets. TESS, or the Transiting Exoplanet Survey Satellite, is a space telescope managed by NASA. Its mission is nothing short of extraordinary: to hunt for exoplanets using the transit method. Imagine a camera that can scan 85% of the entire sky. That's TESS for you. This telescope is equipped with 4 wide-angle telescopes and their trusty sidekicks, charge-coupled devices, CCD detectors. So, how does TESS work? It observes distant stars and sends the data back to Earth every 2 weeks. By carefully analyzing this data, scientists can uncover precious information about the exoplanets in orbit around these stars. TESS has made it possible for us to study the mass, size, density, and orbit of a vast array of small planets. This includes a handful of rocky planets residing in the habitable zones of their host stars. What makes TESS even more exciting is its synergy with the James Webb Space Telescope, JWST. TESS acts as a cosmic talent scout, spotting potential exoplanet candidates for the JWST to scrutinize in more detail. This collaboration makes the work of the JWST considerably easier compared to other telescopes like Kepler and ground-based ones. Before we explore the recently discovered green habitable planet, you need to check this out. As of November 2022, TESS had identified an impressive 5,969 candidate exoplanets. Among these, 268 were confirmed, while 1,720 were dismissed as false positives. One of these confirmed exoplanets is LHS 475b, a fascinating world located 40.7 light-years away from our solar system in the constellation of Octans. LHS 475b is particularly intriguing because of its Earth-like size, with a diameter of about 99% of our home planet. However, don't expect a familiar climate there. This exoplanet is a scorching place with an equilibrium temperature of 586 Kelvin, much hotter than Earth. If it lacks a substantial atmosphere, its dayside temperature could soar to a scorching 748 Kelvin. Another fascinating detail about LHS 475b is its swift orbit. This exoplanet takes a mere 2 days to complete one orbit around its star, indicating that it's likely tidally locked. This means one side is perpetually bathed in sunlight, while the other languishes in perpetual darkness. LHS 475b is not just any exoplanet. It has a special place in the annals of space exploration, as the first exoplanet confirmed by the James Webb Space Telescope. Despite its size, this exoplanet offers a glimpse into what the JWST can do. LHS 475b's transmission spectrum reveals an unusual atmospheric composition, which scientists are still deciphering. Even more intriguing is its proximity to its star. LHS 475b snuggles closer to its star than any planet in our solar system, further raising questions about its environment and the potential for life. The James Webb Space Telescope, JWST, is a game-changer when it comes to studying exoplanets. It's the only known telescope capable of observing and characterizing the atmospheres of Earth-sized exoplanets. By studying LHS 475b's transmission spectrum, scientists have gained insights into the composition of its atmosphere. So what do we know so far? The initial data suggests that LHS 475b's atmosphere is predominantly composed of carbon dioxide. However, more precise measurements are needed to distinguish between a pure carbon dioxide atmosphere and one with no carbon dioxide at all. Additionally, the exoplanet is a bit warmer than Earth, which could hold intriguing clues about its habitability. Clouds could transform our understanding of LHS 475b. If scientists detect clouds on this exoplanet, it could resemble Venus, which boasts a carbon dioxide-rich atmosphere. With more observation data on the horizon, we anticipate further revelations about this intriguing world. Did Tess discover a new planet that can accommodate us? The first Earth-sized exoplanet discovered by Tess was HD 2749b, and this discovery was officially announced on April 15, 2019. This exoplanet orbits the orange main sequence star HD 21749 in the constellation Reticulum. Notably, this star is rather dim and not visible to the naked eye. Credit for this discovery goes to Tess, which has uncovered not just one, but 10 exoplanets around HD 21749. HD 2749b is an exciting find. It's described as a possibly rocky, hot, sub-Neptune-sized exoplanet, and it orbits its star at a distance of 0.08 astronomical units, completing an orbit in a brisk 7.8 days. As for its size, it's about 1.1 times the radius of Earth, making it a relatively small celestial body. HD 21749, the star it orbits, is cooler and smaller than our Sun, with a mass roughly 0.73 times that of Earth. The star's effective temperature is 4,640 Kelvin, and its metallicity, a measure of its elemental composition, is roughly similar to that of the Sun. Tess's discoveries aren't limited to Earth-sized exoplanets. It has also unveiled larger planets that might offer conditions suitable for life. One such example is TOI 700d, a near-Earth-sized exoplanet located in the habitable zone of a red dwarf star known as TOI 700. TOI 700d, discovered about 101.4 light-years away in the constellation Dorado, is a potential gem for scientists. It orbits its star at a distance of approximately 0.163 astronomical units and takes just 37.4 days to complete an orbit. This exoplanet receives about 86% of the energy that Earth gets from the Sun, making it an intriguing candidate for further study. Despite its allure, there's still much we don't know about TOI 700d. For instance, its mass remains a mystery, although it's estimated to be around 1.72 times the mass of Earth, assuming it possesses an Earth-like atmosphere. The average temperature on this exoplanet is approximately 268.2 Kelvin. However, there's a twist. There's a small chance of a runaway greenhouse effect taking place on TOI 700d, emphasizing the need for more exploration. This is where the James Webb Space Telescope, JWST, steps in, with its advanced instruments ideally suited for the job. With further observations, we hope to gain deeper insights into TOI 700d and unlock its mysteries. The search for Earth-sized exoplanets is a monumental quest, and Tess has been instrumental in making significant strides in this field. By exploring these distant worlds, we inch closer to finding out if we are alone in the universe, or if there are other planets that sustain other creatures. Let's look at our potential new home, the habitable green planet, discovered by Webb's. On April 17, 2014, the astronomical community witnessed a momentous discovery, Kepler 186f, an exoplanet located within the habitable zone of the red dwarf star Kepler 186, positioned approximately 5,580 light-years away in the Cygnus constellation. Kepler 186f orbits its star at a distance of about 0.43 astronomical units, completing its orbit in 130 days. With a mass roughly 1.44 times that of Earth and a radius approximately 1.17 times Earth's, it ranks high on the list of exoplanets with potential habitability. This exoplanet's significance lies in its resemblance to Earth, notably in its radius, and its location within the habitable zone of another star. Its existence was brought to light through the Kepler telescope's transit method. Kepler 186, the star around which it revolves, is associated with 5 known planets and possesses an apparent magnitude of 14.62%. It stands as a relatively dim celestial body compared to others. With a temperature of around 3,755 Kelvin and an age of roughly 4 billion years, Kepler 186 is relatively younger than our Sun by approximately 600 million years. Regrettably, Kepler 186f remains beyond the reach of the James Webb Space Telescope, JWST, denying us deeper insights into its potential habitability and the likelihood of life. However, the promise of future telescopes with greater capabilities leaves room for optimism in uncovering more about this distant exoplanet. In 2023, the JWST made a noteworthy discovery, K218b, an exoplanet in orbit around the red dwarf star K218, located 124 light-years from Earth. The initial discovery of K218b dates back to 2015, thanks to the Kepler Space Telescope. Nevertheless, it was the JWST that confirmed the presence of carbon dioxide and methane in its atmosphere, hinting at the possibility of oceans and a hydrogen-rich environment. Should these indications prove accurate, it opens the door to the prospect of a new Earth-like colony. K218b completes its orbit around its star in a mere 33 days, and its mass, roughly 8 times that of Earth, positions it within the habitable zone of its star, receiving a comparable amount of starlight to Earth. It has been dubbed mini-Neptune due to its potential hydrogen-rich envelope, prompting scientific contemplation regarding its composition, whether rocky with a thick envelope or more reminiscent of Neptune. Further observations suggest K218b's likely tidal locking, with an equilibrium temperature hovering around 250 Kelvin. While tidal heating is considered improbable, Hubble Space Telescope observations indicate the presence of water in the atmosphere, with hydrogen dominating while ammonia concentrations remain too low to measure. K218b serves as a test case in exoplanetary studies, offering insights into the potential for life on this intriguing exoplanet. The cosmic clock steadily ticks, urging us to patiently await answers while envisioning the possibility of making this distant world more accommodating for our future exploration. These discoveries open doors to a universe full of prospects, emphasizing our relatively small role in the vast cosmic narrative. With each revelation, our collective curiosity is piqued, inspiring future generations to explore the mysteries of space. There are several theories by scientists exploring the concept of finding an alternative planet for mankind. Some of the most notable are the rare Earth hypothesis and Fermi paradox. The rare Earth hypothesis, proposed by astrophysicists Peter D. Ward and Donald Brownlee, suggests that the conditions necessary for complex life, similar to what we find on Earth, are exceptionally rare in the universe. It posits that a delicate balance of factors, including a stable star like our Sun, a terrestrial planet with a large moon to stabilize its axial tilt, and the presence of protective gas giants like Jupiter, are all vital prerequisites for fostering advanced life forms. The rare Earth hypothesis also contends that cosmic events, like asteroid impacts and supernovae, must occur at just the right frequencies and intensities to create a habitable environment. If these conditions are indeed rare, it would explain why we have yet to discover conclusive evidence of extraterrestrial life. In essence, This hypothesis underscores the remarkable uniqueness of Earth's life-sustaining environment in the vast cosmos, implying that Earth-like conditions may be exceedingly uncommon. The Fermi paradox, on the other hand, encapsulates the perplexing question of why, given the vast number of stars in our galaxy and the likelihood of many of them hosting potentially habitable planets, we have not yet detected any sign of extraterrestrial civilizations. The paradox is named after physicist Enrico Fermi, who famously posed the question, "Where is everybody?" Several hypotheses attempt to explain this paradox. One possibility is that intelligent life is indeed common in the universe, but advanced civilizations tend to self-destruct before becoming technologically capable of interstellar communication or travel. Another explanation is that we may not be looking in the right way, or advanced civilizations might be using communication methods beyond our current detection capabilities. Some propose that advanced civilizations could be deliberately avoiding contact with less developed ones. The exploration of space for an alternative home is not merely a futuristic fantasy, it is a bold endeavor driven by compelling reasons. Consider the vulnerabilities of our planet, susceptible to existential threats such as natural disasters and climate change. Thus, discovering a backup habitat is not just a smart move, it is a crucial insurance policy for the survival of our species. Furthermore, the challenges posed by our growing population and depleting resources emphasize the significance of space exploration. By venturing into space, we open up possibilities of utilizing off-world resources, including the water found on the Moon, Mars, and Kepler 186f. This not only satisfies our needs, but also alleviates the strain on our planet's environment. However, the benefits extend far beyond resource acquisition. Space exploration offers a treasure trove of knowledge waiting to be discovered. From comprehending distant exoplanets to inventing technologies that enhance our lives on Earth, the potential is infinite. Additionally, let us not overlook the unifying effect it has on a global scale. Collaborative space missions bring nations together, transcending political boundaries in pursuit of a shared objective. Space exploration to find a new home for humans has its challenges. The vast distances between celestial bodies require the development of advanced propulsion technologies to facilitate travel to other planets. Overcoming the difficulties of providing life support for extended missions, mitigating the effects of cosmic radiation, and establishing self-sustaining colonies in harsh extraterrestrial environments is a complex undertaking. Addressing these challenges demands thorough planning, innovative solutions, and collaborative efforts on an international scale to bring the vision of human space colonization to fruition. Investments in space exploration, particularly in the search for habitable planets beyond Earth, have gained unprecedented momentum in recent years. Leading this endeavor is Elon Musk, the visionary entrepreneur behind SpaceX. Musk's ambitious aspiration to establish a human presence on Mars represents a pioneering effort that necessitates substantial investments, innovation, and technological advancements. Musk's vision is clear, transforming humanity into a multi-planetary species by enabling colonization on Mars. This goes beyond brief visits by astronauts. It entails establishing a self-sustaining and flourishing human settlement on the Red Planet. While Musk's vision of Mars colonization is undeniably bold and demands significant financial support, it epitomizes the spirit of exploration that has propelled humanity to surpass its limits throughout history. As investments in space exploration continue to flow, the dream of establishing a human presence on a habitable planet beyond Earth draws closer to reality, marking an epical chapter in our cosmic journey. Thanks for watching. Check out the video you see on your screen right now, it's unbelievable.